Take a moment to read Unit 4, Lesson 9, Problem number 2, From Ratios to Angles. In this activity, students are calculating the measure of missing angles and sides. Previously, students have found missing side lengths in right triangles when given one acute angle and one side length using trigonometric ratios. Throughout this activity, I will be using a Desmos scientific calculator. This activity also allows students to choose which method they'd like to solve each problem. I will show a variety of ways to think about each of these problems. One thing that I do want to remind is that students created a table of ratios about these different functions. We have since given each one of those columns a name: cosine, sine, and tangent. Those are our trig functions that we will be using throughout part of this activity. Students can choose between using the Pythagorean theorem, trig functions, or the triangle sum theorem. And like I said, I will use a variety of those through these problems. So let's start with the first example. So notice we have a right triangle and it has a side length of 9 and a side length of 10. We do not know two angles and we do not know a side. So when it says solve for all missing sides and angles, I do have 3 calculations that I will need to be doing. I am first going to start off with using the Pythagorean theorem. I'm going to do that because I want to find how long side A to C is. So I'm going to use the Pythagorean theorem, which again says a squared plus b squared equals c squared, where c is my hypotenuse. So here's c. And then a and b are the legs, a and b. All right, so I'm going to go ahead and substitute in my values. So I'm going to have 9 squared plus x squared equals 10 squared. I know that 9 squared is 81 plus x squared, and I know 10 squared is 100. To get x by itself, I will subtract 81 from each side. 81 minus 81 is 0. I have x squared equals 19. Oops. And then I have to take the square root of each side because I do not want x squared. So I do need a calculator for this, so let's just pull up Desmos and we're going to do the square root of 19. And it tells us it's 4.35 with a bunch of other numbers. I'm going to round it to the tenths place, so I'm going to call this 4.4. Okay, so I have calculated that side length A to C is 4.4 units. Okay, I'm going to go back and erase the A, B, and C because I am not going to need that in the next part that I do. So now I need to find one of my angle measures. It does not matter which angle measure you choose to find. You're still going to use trig ratios. You may just use a different trig function than I'm going to show you. So I'm going to pick angle C. That's the angle that I'm going to find. When I do that, I am going to use 9 and 10. I am not going to do 4.4. The reason being, if I got that answer wrong, I don't want all of the rest of my problems to be wrong because I'm using an incorrect length. So I'm going to use 9 and 10. I can see that 10 is my hypotenuse, so I'm going to label it as so. And I can see that 9 is opposite of the angle that I'm trying to find. We need to look at our table to determine, are we using cosine, sine, or tangent? I see that I need both opposite and hypotenuse. The only one that has both of those measurements in a ratio is sine. So in order to find angle C, I'm going to use sine. I do not know the angle measure, so I'm going to put my theta symbol. Again, that's a Greek letter. Just it represents a variable, something that we don't know. And then when I calculate my ratio, I need to put my opposite leg, which I said was 9 units, and I need to divide it by my hypotenuse, which is 10 units long. We notice that if we want to get theta by itself, we have to take the inverse of sine. When we take the inverse of sine, it looks like this, sine to the -1, and then we're going to keep our ratio that we built. So at this point, I am going to go back to my calculator, move it over here this time, and I'm going to show you how to put this in. First of all, you do need to make sure that it is on the degrees. Okay, you don't want it to say radians. We're not doing radians at this point, just degrees. So to get the ones that have an inverse, notice I see sine, cosine, and tangent, but if I click up here on this func, F-U-N-C, the function button, I can go ahead and choose. Oops, hold on. Let me go back because I forgot to hit enter to get a new line. So I'm going to do sine, the inverse of sine, and then I'm going to come back to the main, and that's going to allow me to type in my fraction, 9/10. Okay, it says that it's going to be 64.15 degrees. I'm going to round it to the nearest degree, so I'm going to say it's 64 degrees. So theta is 64 degrees. So I know angle C is 64 degrees. Now from here, you could use another trig ratio to find out angle B, but we know from previous units that all three angles inside a triangle must add up to 180 degrees. So if I know that angle C is 64 degrees, I know that angle A is 90 degrees, and I am looking for angle B, which I'm going to call the letter Y. Oops, that is a really bad Y, so let me change that. I'm going to call this one Y. I know that this has to equal 180, so I'm going to add 64 plus 90, which gives me 154, plus Y equals 180. And then if I subtract 154, that will isolate Y, because 154 minus 154 was 0, and 180 minus 154 is 26. So I know that angle B is 26 degrees. Okay, notice in this problem, we first used Pythagorean theorem, then we did trig ratios, then we did the triangle sum theorem. In problem number 2, I am going to show you using trig 2 times and the triangle sum theorem. So let's go ahead and take a look. The first thing that I'm going to do this time is I'm going to find one of my angle measures. So I'm actually going to find angle D. I'm going to start with that. So I can see that the 7 is going to be my hypotenuse, and my 4 is going to be my adjacent side. So that means that I need to this time use the cosine function. So I'm going to go ahead and do it on the left. So I'm going to say cosine of my angle, which I don't know how big it is equal to the ratio of the adjacent leg 4 over my hypotenuse, which is 7. Again, to solve and get theta by itself, I have to do the inverse of cosine. And then I continue to leave my ratio 4/7. So let's pull the calculator back up. Okay, we have to go to function, inverse of cosine 4/7, and it tells me that's about 55 degrees. So I know angle D equals 55 degrees. Okay, I'm actually going to write that in my diagram. 55 degrees. I can now use that to help me figure out what is my opposite side. Now, I can pick either the adjacent or hypotenuse. I'm going to pick the hypotenuse. So when I do that, I know that I'm going to use the sine function. But notice that this time, I'm going to have to use my 55 degrees. I already know one of the angle measures. Okay, my fraction is going to represent, I'm going to put the opposite side as x. X, divided by 7. That's going to be my ratio. All right, to get x by itself, I see x is being divided by 7. I know the inverse of dividing is multiplying. So I'm going to multiply each side by 7. All right, so I'm going to go back to my Desmos calculator. And I'm going to go ahead and put in. Notice that this time we're not taking the inverse of sine. It's just sine. So we're going to type in 7 times sine of 55 degrees. And it's going to tell me that my length of that side is going to be 5.7 units long. Okay, so I know that side EF is 5.7 units. Okay, last thing I'm going to use is my triangle sum theorem. I know all 3 of these angles inside the triangle must add up to 180 degrees. So I'm going to do 55 plus 90, which is going to give me 145 equals 180. And then I'm going to subtract 145 from each side, and I see that angle E is going to be 35 degrees. Okay, notice this time I did use trigonometry 2 different times, once to find an angle, once to find a side, and then I did the triangle sum theorem. I want you to take a minute and challenge your student to try number 3. And then you can go ahead, so I would pause this video, and then when you're ready, you can check it now.